So good morning class. So before some days I have given you some questions regarding refractive index. So today I'm gonna solve these questions. So first question was light is going from medium x to medium y, and if the ratio of the speed of light in medium x to medium y is 3 by 2 or 3:2, then find the refractive index of medium x with respect to y. This I didn't write on that sheet. So suppose we have an interface AB, and above this interface we have medium x having velocity v1, and below this medium y with velocity v2. So what is given? v1 by v2 is 3 by 2. So this is the ratio that is given. So suppose a light is going from medium x to medium y. So at the point of incidence we can draw a normal, and if suppose there is no medium, then light should go like this. But since this is a medium, light will go like this. Okay, so light will bend. This is called refraction. Now PO is incident ray, OQ is refract. So PO is incident ray and OQ is refracted ray. Now refractive index of medium x with respect to y, it will be what? The velocity of light in medium x will be in denominator, and in numerator it will be v2. Okay, so from here v1 by v2 we have given 3 by 2. So from here we can calculate v2 by v1. So v2 by v1 will be 2 by 3. Okay, hence we can say the refractive index of medium x with respect to y is equals to, that is v2 by v1, and v2 by v1 is 2 by 3. So this will be 2 by 3. Now you might be thinking that a different solution, that we know that refractive index of medium x with respect to y is nx by ny. That formula I have given to you, and let this is equation 1 and this is equation 2, and if we compare these two equations we will get then nx equals to 2. So if we compare this and this, we will get nx equals to 2. But this is not the answer. This is completely wrong, because this is not how we compare the ratios. Okay, so this is wrong. What will be our answer? Our answer will be 2 by 3. So this will be our refractive index. So this is our answer. Clear? So next question is, when the light goes from air to medium x. So we have a medium air and another medium x. Its speed is decreased by 20%. If it is going air to x, its speed decreases by 20%. Now the same light, if it goes from air to medium y, its speed decreases by 30%. So what we have to calculate? Find the refractive index of x with respect to y. How will we calculate it? So we know that the speed of light in medium x will be 80% of the speed of light in air, because 20% is decreased. So if 20% is decreased, what will be the speed of light in x? It will be 80% of the speed of light in air. That is, speed of light in medium x, which we call Vx, will be c times the 80%. C is the speed of light in air. So Vx will be c into 80 by 100, and if we cut this, we will get velocity of light in medium x will be 3 into 10 to the power 8 into 4 by 5, and this is going to be 2.4 into 10 to the power 8 meter per second. So this is the speed of light in medium x. Similarly, we have to calculate the speed of light in medium y. How we will calculate? Same. If 30% is decreased, now what will be the speed of light? This will be 70%. Okay, so similarly it will be 70% of the speed of light. From this we can calculate the speed of light in medium. So this is y, sorry, this is not x, this is y, this is y. So velocity of light in medium y will be 2.1 into 10 to the power 8 meter per second. Now from here you can see which one is denser and which one is rarer. So this is what speed of light is maximum in this case. So it is rarer and this one is denser. So y is denser and x is rarer. Now we have to calculate the refractive index of x with respect to y. So refractive index of x with respect to y will be, refractive index of medium x means velocity of x will be in denominator and in numerator it will be vy. So this is going to be 2.1 by 2.4. So this is 0.88. So refractive index of medium x with respect to y will be 0.88. Similarly, we can calculate, or we know that the formula refractive index of medium x with respect to y is equals to 1 upon refractive index of y with respect to x. So this is going to be 1 upon 0.88. So its value is 1.14. Okay. So refractive index of medium x with respect to y is 0.88 and refractive index of medium y with respect to x is equals to 1.14. So both are our answers. Okay. Now next question is, the distance between Alwar, that is in Rajasthan, to Satpuli, that is in Uttarakhand, is 257 km. And the optical fiber cable. So optical fiber cable is a cable which transmits the information. Okay. So we give a light signal to one end of the optical fiber cable and the same information transmits to other end. Okay. So the refractive index, if we are dealing with the light, then we can say, talk about the refractive index. Okay. So optical fiber cable of refractive index 1.55 is placed between these two cities. How much time the light signal will take to go from Alwar to Satpuli? So this is quite simple question. So suppose we have Alwar here and this is optical fiber cable to Satpuli and the distance between is 457 km. Now we have to keep in mind that this is given in kilometer, but we will deal in meter. Okay. So refractive index of optical fiber cable, that is NF, is equals to 1.55. So we know that a refractive index is given by velocity of light in air divided by the velocity of light in that medium. So it is fiber cable. So NF equals to C upon VF. Okay. So this is our equation 1. Okay. So from here we know that C is the speed of light and VF is the speed of light in optical fiber. So from this we can calculate the velocity of light in optical fiber. Okay. So what will be the velocity of light in optical fiber? This will C by NF. So we know that the C is 3 into 10 to the power 8 meter per second and NF is 1.55. So this is 1.94. Now from 9th class you know that time is equals to distance upon speed. So time is equals to distance is in 457 kilometers. So we have to convert it into meter because we are dealing with the meter per second. Okay. So this distance we have to convert in meter. So this is 457,000 meter divided by 1.94 into 10 to the power 8 meter per second. So meter to meter cancel and this will be second. Okay. So time, unit of time is also second. Now this is, so this is 2.35 into 10 to the power minus 3 second. So at this time the one information will reach to the other end. Okay. So the light signal will take 2.35 millisecond to go from Alwar to Satpuli. So 10 to the power minus 3 second is also called 1 millisecond. So 2.35 into 10 to the power 3 second will be 2.35 millisecond. Okay. So in 2.35 millisecond, one information will go from the Alwar to reach the Satpuli. Okay. So going to the next question. Light is going from medium 1 having refractive index 1.4 and velocity v1. So the velocity in medium 1 will be v1 and its refractive index is 1.4. Similarly for medium 2, refractive index is 2.6 and velocity is v2. And we have to calculate these ratio. So this is the most simplest question that I have given to you. Okay, so suppose we have interface. Again, you know the figure. This is medium 1 having velocity v1, and this is medium 2 having velocity v2. Okay, so refractive index of medium 1 is 1.4. Okay, and refractive index of medium 2 is 2.6. We know that the relation between refractive index and velocity, you know that this is n1 is equals to v2 by v1, and n2 is equals to v1 by v2. Clear? So v2 by v1 is equals to 1 by 4. So n1 is 1 by 4, and what will be n2? N2 is 2.6. So v1 by v2 is equals to 2.6. So these are our answer. This was the quite simple question. Okay, so you have to keep in mind the formula for refractive index in terms of velocity. That will help you. Okay, so next question. A light beam is incident perpendicularly from a height of 200 km from the air to the tank having water in refractive index 1.33. If the total time taken by the light to go and come back, the starting point is 22 into 10 to the power minus 4 seconds. So this value that I have given to you in your assignment sheet was misprinted. So the correct value is 22 into 10 to the power minus 4 seconds. So this value you have to take. So then find the depth of the tank. So suppose we have a light source and we have a water tank. So light is going from this source to water tank in air, and it goes in water. Then after a reflection, it bounces back and reaches to the source. So the distance between source and water tank is 200 km. The distance, or we can say the height of the tank, we have to calculate. Let us assume it is h, and the time taken to go light from there and come back to there will be is 2 into 10 to the power minus 6 second. Okay, so we know that the time taken by the light to reach to the surface of the tank means from here to here, it will take the distance between the tank and source. So this is this distance, which is 200 km, divided by the velocity of light in air, and we know that the velocity of light in air is 3 into 10 to the power 8 meter per second. So this is 200 kilometers, so we have to convert it into meter. So time of light to in air, this will be 2 into 1 2 3 4 5, 2 into 10 to the power 5 we can say, and divided by 3 into 10 to the power 8. So this is going to be 6.66 bar into 10 to the power minus 4 seconds. So in this time period, light will go from there to there. Okay, now t is the total time taken by the light. So this t is the total time to go there and bounce back, but we don't want these two times. So if it is going from there to there and there to there, so we have to just want this calculation. Okay, so how much time the light will take from there here to here. So this we have to do. How we can obtain this? We have to divide this total time by 2. Why this is 2? Why this is 2? Because we don't want the coming light. Okay, so this is wrong. This value is wrong. This is not. This is 22 into 10 to the power minus 4 second. Okay, so t by 2 is equals to 22 into 10 to the power minus 4 divided by 2. So this is 11 into 10 to the power minus 4 second. Okay, are you getting? Means the time that was given to us was the time from light going from source to tank and tank to source, but we want the light from source to tank. How much time the light will take to go from source to the bottom of the tank? That's it. So we have to calculate, we have to divide this time by 2. Okay, so this is 11 into 10 to the power minus 4 second. Okay, so time taken by light to travel in water, it will be, what is time? Time is equals to, what is time? Time is equals to, we have this distance and this total time minus this time. Okay, so how much time it will take? So we know that this total time, which is t by 2, this total time is t by 2, and this time we know this is 6.66 into 10 to the power minus 4. So we can calculate this time from the surface of the tank to the bottom of the tank. So this will be 11 into 10 to the power minus 4 minus 6.66 into 10 to the power minus 4. So this is going to be 4.32 into 10 to the power minus 4 second. Clear? So from here to here, light will take this much time. Okay. So now the refractive index of water, we know that this is 1.33. And the formula for refractive index is C by velocity of light in water. So from here, we can calculate the velocity of light in water. Okay. So velocity of light in water will be C by refractive index of water. So this is 3 into 10 to the power 8 divided by this refractive index. So this is going to be velocity of light in water is 2.55 into 10 to the power 8 meter per second. Okay. So we know that the time, we know that the velocity, we can calculate the distance. So distance is equals to speed into time. So speed is this 2.5 into 10 to the power 8 divided by time, this much time it will take. So this will be the height. So 11 into 10 to the power 8 minus 4, because these are multiplication, so power will add up. So this sign is negative, so it will subtract. So h is equals to 11 into 10 to the power 4 meter. So this is the height of the tank. So if we convert it into kilometer, so this is going to be 110 kilometer. Okay, so this is our answer. So the height, or we can say depth of the tank, will be 110 kilometer. Clear? So first we have to calculate the speed of light in tank, and then we have to multiply with time, and we will get the height. So this was the little bit difficult problem, but quite simple. Now we have fifth question. The light is incident from a medium 1 having refractive index 1.5 with angle of incidence 30 degree. If it goes to medium X, in which the velocity of light is 2.5 into 10 to the power 8 meter per second, what is the angle of refraction? So how we can solve it, this question? So first we have given the refractive index of medium 1 is 1.5. Okay, and the velocity of light in medium 1 is v1 is equals to c by n1. How? Because we know that n1 is equals to c upon v1. This is the formula for refractive index, or we can say absolute refractive index. So from here v1 we can calculate, this is c by n1. So this is 3 into 10 to the power 8 divided by 1.5. Okay. So the value of this is 2 into 10 to the power 8 meter per second, means the velocity of light in medium 1 is 2 into 10 to the power 8 meter per second. 2 into 10 to the power 8 meter per second. So the velocity of light in medium 2 is 2.5 into 10 to the power 8 meter per second. This is given in the question. Okay. So we have to calculate the refractive index, angle of refraction, sorry. So we know that from Snell's law, the refractive index of medium 2 with respect to 1, because light is refracting in medium 2. Okay, light is incident from medium 1 and it is refracted in medium 2. So we have to calculate the refractive index of medium 2. So refractive index of medium 2 with respect to 1 is equals to sin I by sin r. This is Snell's law. We have already studied it. Okay, so this is equation 1. And we know that refractive index of medium 2 with respect to 1 in terms of velocity is equals to v1 by v2, because if we are calculating the refractive index of medium 2, then its velocity will be in denominator. Okay, so this is our equation second. So we can compare these two equations. So comparing these equation 1 and 2, we get sine I by sine R is equal to V1 by V2. Okay, so from here we can calculate the value of sine R, which is V2 into, so this dot indicates multiplication, sine I divided by V1. So sine R is equals to V2 is 2.5 into 10 power 8 meter per second, multiply by sine I is 30 degree, so this is sine 30 degree divided by V1 is 2 into 10 power 8 meter per second. Okay, so we know that sine 30 is 1 by 2. So calculating this, we get the value of sine R is equal to 0.62. So this is answer for you. Okay, so you don't know the inverse trigonometry. Okay, so you cannot calculate the value of R, but if you want to calculate the value of R, you have to just divide this sign by this expression, or we can say we can take the inverse of the sign. Okay, so R will be sine inverse 0.4. So how you can calculate? So if you have calculator, okay, so find this function in which sine to the power minus 1 is written, and then press this and put the value 0.4, you will get R is equals to 38.3 degree. So our angle of refraction will be 38.3 degree. So this is our answer. So these are the question given by me some days before, and only a single girl, I don't know what her name, but she tried to solve, but no one else show me the interest in solving these questions. No one. Okay, so if you will not take interest in doing such questions, so how will I form the question for you? Okay, so please give me feedback whether you want these type of questions or not. Clear? So these are the solution for these 5 questions. So if there is any difficulty in any questions, you can ask in the comment section. Okay, so thank you for today class.